Hello, today I'm going to review triangle classification theorems. Basically, we're going to learn how to classify different triangles as right, acute, or obtuse, depending on different theorems. Here are the different words we're going to look at, and all these words are review from what we've seen before. We've looked at an acute angle, we know what a converse is, obtuse angle, and right angle. All these things we've looked at before. Before we jump into anything, let's do a brief review of what we saw in Unit 6, Lesson 1, the Pythagorean theorem. So basically we learned that we can either use the Pythagorean theorem to prove that a triangle is a right triangle, or we can use it to find a missing side of a right triangle. And the Pythagorean theorem is written as a squared plus b squared equals c squared, where the measure of our c side squared is equal to the sum of a squared plus b squared. So basically, here's an example. We're asked, what is the value of c in the right triangle? Well, in this example, we are told exactly what a, b, and c are. And we're looking for c. So a is 3, so I'll do 3 squared plus b is 4. 4 squared equals c squared. So we're trying to locate c squared. Well, 3 squared basically means 3 times 3, which is 9. 4 squared basically means 4 times 4, which is 16, equals c squared. So 9 plus 16 is 25, equals c squared. Now I'm looking for c, not c squared. So how will I go about finding this? Well, the way we can go about finding this is to actually take away the squared. And the way you would take away the squared is by using a square root on both sides. By using the square root, we can go ahead and cancel out the square and the square root on this side, leaving us with the square root of 25 equals c. Now, whenever we can actually find the square root, like in this example, we can go ahead and write that in. So the square root of 25 is one of two things. We can either multiply 5 times 5 to get 25, or we can multiply -5 and -5 to get 25. However, because we're looking at side lengths, what we want to use is the positive because you can't have a negative side length. So 5 times 5 is the square root of 25. So 5 is the square root of 25, which means that c is 5. So I identified that the value of c is 5. And then here we are told the exact same thing I just repeated. For the square root, you do get a positive and a negative value, but we only use the positive here because we are dealing with side lengths of a triangle. So that's a review of Pythagorean theorem. So let's move on a little further. Get into the second slide, and this is setting up the proof for the converse of the Pythagorean theorem. So basically, the Pythagorean theorem tells us that if we can take the side A and square it, plus the side B and square it, in order for that triangle to be a right triangle, the sum of a squared plus b squared must be equivalent to or equal to c squared. So that's what we learned from the Pythagorean theorem. If our sides satisfy this equation, then we can automatically assume that we have a right triangle. So an example of that would be if I told you that for my triangle ABC right here, that a squared plus b squared equals c squared was in fact true, well then I can assume from there that this would be a right triangle. I can't just assume it's a right triangle, but once I plug it into the Pythagorean theorem, I can therefore assume it's a right triangle if it does in fact equal to c squared. The converse of that would be us already knowing that the triangle is a right triangle, like we see here in DFE. And then once we know that it's a right triangle, well, then we can go backwards. And if we're missing a certain angle or a certain side length, then we can use a squared plus b squared equals c squared to solve for that missing side length. Because if it's a right triangle, then the sum of a squared plus b squared must be equal to c squared. Okay, so that's the converse of our original theorem. Does anyone have any questions? Pretty straightforward. And so we would use this idea to prove that a triangle is a right triangle, and then we would use this idea to find the missing side of a right triangle. That's basically the takeaway here. Okay. So the converse of the Pythagorean theorem states that if the square of one side of a triangle is equal to the sum of the square of the other two sides, then the square is a right triangle. So that's what we saw before. If we can prove that a squared plus b squared is equal to c squared, then I can prove that it is a right triangle. Right? Okay. Well, here's some other information that this slide is going to tell us. C, if it is a right triangle, is always going to be the longest side. C is always by itself on one side of the equation side. So in order for C to be equal to these two sides added together, A and B, then C would obviously have to be longer than A and B, right? Because C would have to be equal to the sum of A and B. So C would always be the longest side. Okay, so C is always our longest side. Our hypotenuse is always our longest side. That's the big takeaway here. Our hypotenuse is always the longest side in a right triangle. Okay. Now what we're going to do is we're going to go ahead and look at how we can fix or alter the Pythagorean theorem for other types of triangles. But before we do that, let's just go ahead and check for understanding just to make sure we know how to use the Pythagorean theorem. So here we've used the converse of the Pythagorean theorem to determine whether each triangle is a right triangle. So we're trying to determine that we can use the Pythagorean theorem to solve or to prove that that triangle is a right triangle. Okay? So what we want to do is put a squared, oh my goodness, sorry. A squared plus b squared equals c squared. That's what we'll start off. We want to identify what our c squared is. Again, our c squared is always our longest side. So 5 is greater than 3 or 4, so 5 will be our c. So, and then a and b are interchangeable. So I'll just do 3, 2, and 4, 2. So now I want to go ahead and see if this is true. Does the sum of these two sides equal the sum of that side? Well, again, this is 3 times 3, which is equal to 9. This is 4 times 4, which is equivalent to 16. And then this is 5 times 5, which is equivalent to 25. And then 9 plus 16 is 25. So 25 does in fact equal 25. So therefore, we can satisfy the Pythagorean theorem. So we can prove that this triangle is in fact a right triangle. Does anyone have any questions about that? Okay, now let's try this other triangle. Can we prove that this triangle is a right triangle? Well, let us see. Again, we want to use a squared plus b squared equals c squared. And if it does, in fact, equal c squared, then it will be a right triangle. Again, c is always going to be our largest side, so 10. So I'll plug those in. Oops, sorry, guys. Let me just zoom in. Okay, so 10 squared. A and b are interchangeable, so I have 4 squared plus 9 squared. Okay, what does this mean? This means 4 times 4, which is 16. 9 squared means 9 times 9, which is 81. And then 10 squared means 10 times 10, which is equal to 100. So now I want to add 81 plus 16. 81 plus 16 is 97. And 97 is actually not equal to 100. So therefore, this triangle is not a right triangle, right? Because my sum of a squared plus b squared is not equal to c squared. Anyone have any questions? And let me just go ahead and fix this. I put that to be squared, but yeah. Any questions? Okay. So now we're going to go ahead and take the Pythagorean theorem and use it to see what it would mean for acute angles and obtuse angles. So we're going to look at the acute triangle inequality theorem. And the acute triangle inequality theorem states that if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. So what does this say? Well, this basically says that my longest side, the square of my longest side, remember my longest side is always my C. So it says if the square of my longest side is less than the sum of my other two sides, so my A side and my B side, well then that triangle must be acute. So whenever we try to prove if a triangle is acute, we can use this equation right here, where instead of C squared being equal to A squared plus B squared, C squared is actually less than A squared or B squared. Anyone have any questions? So more specifically, this is saying C, whatever C is less than the sum of A and B. Okay. Any questions? Questions? Okay. Now let's see what this means for the obtuse triangle. So the obtuse triangle, or the obtuse triangle inequality theorem, states that if the square of the length of the longest side, so C is my longest side, is greater than the sum of the square of the lengths of my other two sides, then that triangle is an obtuse triangle. So this says if the square of my longest side, so C is always my longest side, that's what we looked at. If the square of my longest side is greater than the square of the sum of my other two sides, well then that triangle must be obtuse. So in order to prove triangles obtuse using the side lengths, we could go ahead and use this equation right here. Does anyone have any questions about that? So acute, C squared would be less than, and here C squared would be greater than. So C is greater than the sum of A and B. Okay. Any questions? No? Okay. So now we're going to see an example problem. And this says, applying the triangle inequality theorems and the converse of the Pythagorean theorem, classify the triangles as an acute triangle, an obtuse triangle, or a right triangle. All three types of triangles classifications begin with comparing the square of the longest side to the sum of the square of the other side. So basically, we have this triangle, and we're going to see whether it's acute, obtuse, or right. And the way that we do that is we need to identify the largest side, so 8, and then plug it into our original Pythagorean theorem and see if it applies. So a squared plus b squared equals c squared. C is always our largest side, so 2 squared. A and b are interchangeable, so, oops, sorry, I didn't mean to write that 3. Like that. Again, this says that 3 times 3, which is 9. This is basically saying 7 times 7, which is 49. And then this is basically saying 8 times 8, which is 64. Now we're going to see 49 plus 9 is 58 is equal to 64. Well, it's obviously not equal to 64, right? So we know it's not equal to 64. So it's not a right triangle. So we can go ahead and cross that one out. Not a right triangle. But we want to see if C is greater than or less than the sum of my other two sides. Well, it looks like C would actually be greater than my other two sides. So C is greater than my other two sides. But what did we see? Well, we see that the obtuse triangle inequality theorem tells us C is greater than the sum of A and B, which we see right here. So this triangle would be an obtuse triangle. Okay. Does anyone have any questions about that? Questions, concerns? Okay. Now we're going to see what a real world example might be, or an example problem we might encounter. This one says, Jax is setting up an obstacle course for his campers in the shape of a triangle. We have a triangle. The distance from the first to the second obstacle is 60 feet, and from the second to the third obstacle is 60 feet. So that's what's mapped here. How far can he place the third, obstacle form to, how far can he place the third obstacle from the first so that the course is an obtuse angle? So we want to make sure that this is an obtuse angle. Okay? So in order for it to be an obtuse angle, what we know is that we have to have the sum of our two sides be less than the sum of our longest side, or the sum of our largest side must be greater than the sum of our other two sides. Okay? Well, we see here that both of these sides are 60, so they're not greater or less than the other side. So that means that this would be C. This would be our greatest side. So we want to identify what C must be in order for it to be an obtuse triangle. So what we want to do is plug in what we're given. We're told that A and B is interchangeable, so 62. And what we're looking for is what C is that makes it greater than my other two sides. So like this. Again, this means 60 times 60. This also means 60 times 60. 60 times 60 is 3,600, which when we add it together must be less than the square of my remaining side. This is equal to 7,200, which again must be greater than the square of my remaining side. How do I find what my remaining side must be? Well, I can go ahead. Let me move this. I will square both sides to eliminate my square, which leaves me with the square root of 7,200 is less than the measure of C. The square root of 7,200 is 84.85. And so this gives me my answer, which basically says that C must be greater than 84.85. So any number greater than 84.85 can be my C in order to make this obstacle course obtuse. Okay. Anyone have any questions about this? So basically, we're already told that we need it to be an obtuse triangle. So we can use this equation for our obtuse triangle, the Pythagorean theorem for obtuse triangle. We plug what we know in, and then once we do that, we can solve that C must be greater than, right? C is greater than the square root of my other two sides, okay? So what did we review today? We learned that triangles can be classified as right, acute, or obtuse given only the values of the side lengths. So a right triangle is based upon the converse of the Pythagorean theorem, which basically means if we can prove that a squared plus b squared equals c squared, then we can prove that that triangle is a right triangle. If it's equal, then it is a right triangle. Acute triangles, on the other hand, we need to prove that a squared plus b squared is greater than c squared. And then for an obtuse triangle, we need to prove that a squared plus b squared is less than c squared. So that's how we can differentiate between and classify these different types of triangles depending just on their side lengths. And then another big thing we learned was that the longest side is always our C. So this would be our C, this would be our C, and this would be our C. And then A and B are interchangeable. Okay. Does anyone have any questions? Questions, concerns? Okay. If there's no other questions, you guys may log off, and I will see you tomorrow for a very brief practice. Okay. Bye, guys.